Sometimes our body can feel like a bit of a mystery to us. Why can you eat a food and be okay, but your friend eats something and has a completely different reaction? Why does your partner do a really heavy workout and feels great afterwards? Why do you do something similar and feel exhausted? I'm Kate. I'm a naturopath. One of the areas that I work with a lot are people's genetics. So, this is a summary of the key genes that I like to see when I'm working with someone. So, the first one is one called COMT, catechol O methyltransferase. Don't worry too much about the technical names for these things, but this is a gene that makes an enzyme that's responsible for breaking down a couple of key chemicals in our body called catecholamines. They are adrenaline, dopamine, and estrogen. So if someone has a fast COMT, they break down their adrenaline and dopamine really quickly. And so what that can look like is somebody who copes really well with stress, the person that continues to perform under pressure. But because their dopamine can be on the lower side, what it can also mean is they have a bit of a monkey mind. Their brain tends to jump around. They need that dopamine stimulation from doing multiple things at once. They're the people that pick up their phone while they're trying to watch TV. The slow COMT is the opposite. People with slow COMT tend to build up levels of adrenaline and build up levels of dopamine. I always describe it as someone whose adrenaline tank is up to here. It's always almost at the point of bringing over. It doesn't take very much to push someone with slow COMT over into quite a strong state of overwhelm because the adrenaline is so high. And when they get like that, or when you get like that, it can take quite a while for it to calm back down again because the COMT is working slowly. The next gene is something called interleukin 6, and this one is incredibly helpful. So interleukin 6 is what's called an inflammatory cytokine. So we now know that most chronic health conditions, you name it, depression and mood disorders, autoimmune conditions, your ordinary arthritis that we all get, even things like cognitive decline, all have an inflammatory basis. It all starts with inflammation in the body. And so interleukin 6 can tell us whether someone's predisposed to having higher levels of inflammation or what's called chronic low-grade inflammation. So if you've got what's called a genetic variant or a SNP in this particular gene, you're more likely to get inflamed and stay inflamed. The next one is one called FUT2, and this one is super helpful if you're someone that's dealing with gut issues. So the FUT2 gene regulates what's called your secretor status. 80% of people are what are called secretors, 20% are not. And what that secretion refers to is a compound called 2-fucosal lactose. Big long word again, don't worry about that. But it's an oligosaccharide, which is a long chain of sugars that your guts should secrete to feed your beneficial bacteria. And most people do this, no problem. But if you're one of the 20% of people who are a non-secretor, your gut doesn't make that food. And so what that can mean is the balance of bacteria in your gut can look a little bit different to somebody that does make it. And where in particular it seems to have an impact is lower levels of two key species of bacteria or families of bacteria called Akkermansia and bifidobacteria. And then the MTHFR gene, this is the rock star gene. This is the gene that probably most people will have heard of if they've seen anything about genetic testing, thought about genetic testing as the MTHFR gene. Now, it gets an awful lot of attention, possibly a little bit too much attention from my point of view. Its responsibility is to create a particular form of folate or vitamin B9, which is called 5-methyltetrahydrofolate. Everybody just calls it methylfolate for obvious reasons. And that particular form of folate helps in a cycle in cells called methylation. So having an MTHFR variant can mean that you don't make enough of that particular form of folate, and there may be ripple-on effects as a result of that. But knowing this one gene doesn't tell you everything you need to know about methylation. There are other genes, MTR, MTRR, AHCY, BHMT. There's a whole handful of other genes that actually play an equally important role in methylation. They just didn't get quite the attention of the MTHFR gene. So in summary, the key thing to keep in mind if you're thinking about doing genetic testing, you've had genetic testing done, is genes don't act in isolation. And I really think the MTHFR gene's a great example of that. You can't tell really what's going on with methylation with just that gene knowledge itself. Genes are not your destiny. Just because you have a genetic variant, that doesn't mean something is definitely going to happen. It's just a tendency. A good analogy is the genes are a gun, but the environment pulls the trigger. So of equal importance is still things like diet, stress, your gut health, and your environment. If you found this helpful, you might want to sign up to my newsletter, link below, where I send out a weekly newsletter about everything gut and genetic related. Thanks.